In electrochemistry, we often want to know how much energy a particular cell can deliver or whether a particular reaction is spontaneous. If a cell is not spontaneous, we would like to know how much energy we would need to deliver in order to get the reaction to proceed. In electrochemical cells, we also need to work out which electrode is the cathode and which is the anode. To determine these cell parameters, we need to calculate the overall cell potential. This needs knowledge of the standard reduction potentials of the electrodes, which are shown in the table. Standard reduction potentials are measured in reference to the standard hydrogen electrode, which is given a value of 0 in a manner which is analogous to that of sea level and altitude. In the cell here, we have a zinc metal electrode dipped into a solution of zinc ions as one half cell, and the other consists of a copper metal electrode dipped in copper ions. To work out if this cell is spontaneous or not, we need to look at the reaction and identify which electrode oxidation is occurring at and which one reduction is occurring at. If we look at the reaction below, we can see the zinc cell. We see that is reported that zinc metal goes to zinc ions by losing 2 electrons, and this is an oxidation reaction. If we look at the copper, we see that copper ions are reduced to copper metal atoms. To determine if this cell is spontaneous or not, we need to calculate the cell potential. The formula for calculating cell potential is E0 cell is equal to E0 cathode minus E0 anode. We can determine which electrode is the cathode and which electrode is the anode by looking at the half reactions of the cell. In galvanic cells, oxidation occurs at the anode while reduction occurs at the cathode. So here the zinc electrode is the anode and the copper electrode is the cathode. So we can use those values to substitute into the formula. So E0 cathode is the copper cathode and E0 anode is the potential of the zinc, which is negative 0.76. We are minusing a negative number, so this is equivalent to adding that number. So we can calculate that the overall cell potential of this cell is positive 1.08 volts. Positive means that this reaction is spontaneous and that we have identified the anode and the cathode correctly. Why is it a positive potential spontaneous? Well, to look at reaction spontaneity, we need to look at the delta G of a reaction, and delta G for electrochemistry is negative NF times E, where N is the number of electrons that are transferred, F is Faraday's constant, and E is our electrode potential. If the E is positive, we multiply that by a negative value there. It means we get an overall negative delta G for the reaction, and negative delta Gs for reactions are spontaneous reactions.